Today I will be going over the minimum equal sum of two arrays after replacing zeros problem. So let's read the question first and try to understand what's going on. So we are given two arrays, nums1 and nums2, consisting of positive integers, and our goal here is to replace all the zeros in both of the arrays with only positive integers, such that the sum of elements of both arrays becomes equal. And we need to return the minimum equal sum we can obtain. If this is impossible, we just return -1. So as we can see in example 1, here we can replace the zeros in the following way. So the two zeros in nums1 are replaced with 2 and 4, and the resulting array nums1 is 3, 2, 2, 1, 4, and in nums2 we just replace the other zero with the value 1. And in this example we see that it's impossible to make the sum of both arrays equal because nums2 is bigger than nums1, and we have two zeros here that need to be positive. So in that case, that would mean that if we made this 0, 1 and the 0, 1, it would just be 2 plus 2 plus 2, which is 6. And 6 is not equal to 5. And since there are no zeros here, there's nothing we can do. So first we should count the number of zeros in these arrays. So we can just do the number of zeros in nums1 is just going to be, we're just going to count it. So we're going to use z1 as for nums1, and then the number of zeros for nums2. And then we also want to know the sum, because for example, in example 2, the sum in nums2 was was less than the sum in nums1, and we didn't have any zeros here, which meant it was essentially impossible to make the sum of both arrays equal. And we also want to return the minimum equal sum, so we're going to need the sum for both arrays. Now we need to check for all the cases where it won't be possible to make both arrays equal to 0 or equal to each other. So first, if they both did not have any zeros, then that would mean that we need to check if the sum is the same. So if z1 equals to 0, so if there are no zeros in nums1 and there are no zeros in nums2, then we need to check if they're equal to each other. So if the sum of both are equal to each other, if they are, we would just return one of their sums. Doesn't really matter, they're equal. But if they're not equal to each other, we need to return -1, because in this case it is impossible to make them equal to each other since they both don't have any zeros. There's nothing we can do. They're not equal. Another case is if one of them has a 0. So if z1 has no 0, in this case that means that nums1 has no zeros. So we need to check its sum. So for instance here, the one that doesn't have zeros in example 2, for instance, is nums2. So in that case, the sum here is 5. So we need to make sure that this is greater than nums1, because if this is less than nums1, that means that there's no way, since it has no 0, there's no way we can make it equal to nums1. So we need to make sure that whichever array doesn't have a 0, that array needs to be less than the other array. And if it isn't, we're gonna be returning -1. So if the sum So in this case, z1 is the one that has no zero, so it has to be greater than. But if it isn't, so here we're checking if it isn't. If it's not greater than the other array, that means that we need to check how would this make it impossible. So for instance, if we had 5 here, the sum is 5, and the sum here is 4, but we have 2 zeros, then it's impossible to make both sums equal to 0, because 0 would just be replaced with minimally, the minimum number would be 1. So if we replace both zeros with 1, that's going to be 2 plus the sum. So we need to make sure that the sum of the second one plus the number of zeros that there are. So if there's 2 zeros, that's going to be 2 plus the sum is 4, so that's 6. So if 6 is greater than the sum here, which is 5, it is impossible to make both arrays equal to 0. So we just return -1 for that case. And we're also going to check for else. So in this case, if nums2, or in this case nums1 is equal to 0, so if it's equal to 0, it has no zeros. But if it is greater, like I said, if the sum is greater than the other one, but the other one has zeros, then it's possible that we can make this equal to this array. So in that case, we just return the sum of that array, because if it's greater than, we need to make the other one equal to this array. So in that case, the minimum number would be the sum of 1. And the same thing for in the case where nums2 has no zeros. Then all we need to do is check if the sum in nums2 is less than the sum in nums1 plus the number of zeros in nums1. Because if it is, it's impossible to make both arrays equal to 0. Otherwise, we just return s2, the sum of nums2, because that means that although it has 0, so if nums2 were to be bigger, and this had a lot of zeros, all we need to do is just make this equal to this, because we want to find the minimum equal sum. So we just return that sum. Now in the case where they both have zeros, like in examples 1, we just want to return the max. Between the sum in nums1 plus the number of zeros, so sum of nums1 plus its zeros, and the sum in nums2 plus its zeros. Because whichever one is a max, that's the one we're going to be essentially obtaining the minimum from. So here we see that this is 6, the sum is 6, but it has 2 zeros. So the minimum it can be is 6 plus 2, which is 8. That's the minimum. And the minimum this can be is 6 plus 5, which is 11, plus 1, because that's the minimum, so that would be 12. So the minimum would be 12, and we just return the max for that. And that is all.